This is question 7 of the year 12 June exams. It gives us a part of a curve with the equation y equals 3 cos x, and this is the first few parts are all about transforming that graph. So first of all, it wants us to state the value of C and D, so this coordinate here. So if we think about the graph of y equals cos of x, so without the 3 transforming it, this would be the point negative 180, negative 1. But this transformation here is a stretch, scale factor 3 in the y direction. So the value of C doesn't change. It's still negative 180. There's been no movement this way at all. But the value of D is being stretched 3 times as far away from the x-axis. So it's going to be negative 3. So part A, C equals negative 180, D equals negative 3. So the coordinate is that. That's the point P. Okay, so part B of the question says that we need to state the coordinates of the point to which P is mapped by the transformations below. So we're still starting off with the same y equals 3 cos x. So that part A, we need to use that in our part B answers. So this one, y equals 3 cos of x divided by 4. And that one, if you divide by 4 there, that is a stretch with scale factor 4 horizontally. So it's going to get 4 times as far away from the y-axis. So that is, if it was originally negative 180, negative 3, it's going to be negative 720, negative 3. So 4 times 180 is 720. So B, part 1, is going to be minus 720 minus 3. And part 2, it's subtracting 36 within that bracket. So that's going to be a translation. And that's going to be a translation 36 degrees to the right. So it's going to go 36 degrees that way. So that's going to be negative 144, negative 3. Okay, so that's part B done. And then part C asks us to solve this equation here, 3 cos theta minus 8 tan theta, for theta between 450 degrees and 720 degrees. It specifically says we can't use our calculator to just solve this. So we have to actually think and write down what we're doing. So we're going to need to use some trig identities here. So to start with, one of the things that you hopefully know is that tan theta is equal to sine theta over cos theta. So we're going to substitute that in there. So 3 cos theta equals 8 sine theta over cos theta. And we've got this fraction here. So let's try and get rid of that by multiplying by cos theta. So 3 cos squared theta is equal to 8 sine theta. Now we've got a mixture of cos and sine in our equation, which makes it tricky to solve. So it's better to just have one of those trig functions in there. Now, the other identity that you know, other than this one, is that sine squared theta plus cos squared theta is equal to 1. So if we rearrange that for cos squared theta and substitute it in here, we'll have an equation just with sine squared theta. So we're going to use the fact that cos squared theta equals 1 minus sine squared theta and substitute that in here. So 1 minus sine squared theta is equal to 8 sine theta. Let's expand this left-hand side. And we've got a quadratic. So let's take it all to one side to make it equal to 0. And I think I'm going to factorize that. You could, if you wanted, substitute x in for sine theta and have 3x squared plus 8x minus 3. And so if you feel happier dealing with it like that, and then turn it back at the end. But I think I'm just going to factorize it now. So 3 sine theta minus 1 and sine theta plus 3 is equal to 0. So this one, if I set that equal to 0, I end up with sine theta equals minus 3, which is no good. But this one, because that's outside of the range 1 and minus 1. This one here, 3 sine theta minus 1 equals 0. This is looking more promising. Sine theta equals a third. And that, if I inverse sine that, theta is equal to 19.47 degrees. So I'm almost there. I just need to check because it says solve for theta between 450 and 720. So if I think about my sine graph, it's 180, 360. I'm going to need this one up here. This is the one that's going to be between 450 and 720. That's going to be the only one that works for us. So this is 540. So if I do 540, take away 19.47, that gives me 520.5 to 1 decimal place. And that's the only solution for theta. So theta equals that.